Hey math kids, today we're going to talk about separable differential equations. And yeah, let's just try these two examples. So what we could do is divide both sides by y, which is like multiplying this side by 1 over y. So we get 1 over y dy dx, and then we have that equal to x. And so if we integrate both sides with respect to x, we can think of those canceling. So we have this integral and this integral. And when we do this, it's natural log absolute value y. When we do this, we get x to the 2 over 2, and then plus c. And then if we want to solve that for y, we can e both sides. And if we do it in such a way that we have plus or minus, we can look at it like this. And that's it. Your book takes it one step further and basically says, well, what if it's plus or minus e to the x squared over 2 times e to the c? And then what if we called plus or minus e to the c a? Then we could write that as y is equal to a e to the x squared over 2. I think this is fine though, so just leave it there. Okay. Now, similar thinking here. We're just going to multiply both sides by y squared. So y squared dy dx is equal to 1. Then we integrate both sides with respect to x. These cancel, so we have y squared dy and 1. If we do this, it's going to be y cubed over 3. If we do this, it's just going to be x plus c. And then we multiply both sides by 3. And cube root. Is equal to y. Now, if we multiply c by 3, it's just another constant, so we can just call it another constant. So that's why your book left it like that. But technically this c would be different than this c, but it's still just a constant. But anyway. Okay, solve this differential equation. Given initial conditions. Okay. So what we're going to do, we're going to divide both sides by that. So we get 1 over e to the 2y dy dx is equal to cosine 3x. Integrate with respect to x. These cancel. We get 1, here, let's do it this way. Let's do e to the negative 2y dy is equal to this. Okay. Now, if we take the antiderivative, we rewrite it, and then divide by the derivative of the inside. So we end up with that. The antiderivative of cosine is sine. And then we divide by the derivative of the inside, and we have our plus c. And then we just do some algebra. We're going to times by negative 2, which will bring a negative 2 right there. And then we'll need to take the natural log of both sides. So we're going to have those cancel. So negative 2y is is equal to natural log negative 2/3 sine of 3x plus c. And then divide everything by negative 2, and that will just put a negative 1/2 out in front. So that's what we have. Now if we use the initial conditions, we can plug in 0 for y and 0 for x and solve for c. So 0 equals negative 1/2 natural log negative 2/3 sine 3 times 0 plus c. Alright, 3 times 0 is 0, sine of 0 is 0, this times this is 0, and so we get negative 1/2 natural log of c is equal to 0. We can multiply both sides by negative 2, and 0 equals natural log of c. We take the e of both sides, e of 0 equals c, which is just 1. And so we can just modify this up here, say plus 1. Okay, a salmon farm has an initial population of 80. Population grows according to this differential equation. Where t is years. Write an expression for p in terms of t. Alright, so we have this. We're just going to divide by p, which is like doing that. So 1 over p dp dt equals 1/5. Then we're going to integrate with respect to t. These cancel, and so we're left with this. And then that's going to be natural log of the absolute value of p. And then this is going to be 1/5 t over 5, I guess is how I'm going to write it, plus c. Okay, and then we want to solve. So we take the e of both sides. And we put a plus or minus out there so we can get rid of those absolute values. We do know, let's see, do we know values for p? We know the population is never going to be 0 or below, yeah. So we do know that p is greater than or equal to 0, so we don't need to do this. And so we don't need those absolute values, and so that's just our expression for p. And then, if we want to look at the initial conditions, when t is equal to 0, p is equal to 80. And so if we plug in a 0 right there, we're going to get, 80 is equal to e 0 over 5 plus c. And that's just a 0. That's going to be e to the c equals 80, and that's essentially all we can do, unless we want to do natural log on both sides. Natural log of 80 is equal to c, and so we could replace this with natural log of 80. If you want to see a slightly different approach, you can look in your book. Now, part B, it says find the salmon population after 10 years. And so we're going to just plug in a 10 to this. So P equals E 10 over 5 plus natural log of 80. So that's E2 plus natural log of 80. And so we just go to our calculator. E to the 2 plus natural log 80. And we end up with 591 salmon after 10 years.